All right, welcome to our third notes video for Chapter 7. We're doing square root functions and inequalities. So the first thing we're going to do is consider the function f of x equals x squared. They're going to ask us to find f inverse of x. So if we remember from the last video, when we find the inverse, we're switching our x and y values. So let's find this. So find f inverse of x. So our original function is f of x equals x squared. We really have f of x. We can really rename this as y equals x squared if that helps you look at things differently. So switching our x and y values, we now write this as x equals y squared. All right, so solving for our y value now, or our f inverse, we take the square root of both sides, and we're going to get y is equal to x, or the square root of x. Sorry about that. Let me just change that here. So we're going to have y equals the square root of x, or we have f inverse of x is equal to the square root of x. So the inverse of f of x equals x squared is the square root of x. All right, so graphing these two functions, both f of x and f inverse of x on the same coordinate plane that we have here, let's just graph our f of x first. I'll graph that in red here. And all right, so we just plug in values into our f of x function. So if we have x and f of x, just to kind of help us create our graph. So x values, if we have -2, -1, 0, 1, and 2, just to kind of get us started. So -2 squared is going to give us a 4. -1 squared is going to give us a 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. So if we plot these points out, we're going to get -2. So go over 2 and up 4. So 1, 2, 3, 4. And then we go over 1 and up 1. We have a point 0, 0. We have a point 1, 1. And our point 2, 4. So 1, 2, 3, and 4. So if we just create our little graph, that's what our f of x looks like. All right, so if we plot our f inverse out on the same coordinate plane, so I'll do that in green here. So we have x, and then we have f inverse of x. We have just a couple of values. So if we have -3, well, actually, we'll start with 0. 1, 2, and 3. You'll notice that I didn't go negative because if you put a negative underneath a square root, it's undefined. You're going to come up with an imaginary number. So we'll just start at 0 when we have f of x equals the square root of x. So our f inverse is square root of x. So we have square root of 0 is 0. The square root of 1 is 1. And just to make things easier, we'll just jump down to 4 here. It'll give us a whole number, so the square root of 4 will give us 2. And then our values 0, 1, and 2 will just give us a basic graph. We'll just skip these right here. So if we have our point 0, 0 right here, our point 0, 1, or 1, 1, 1, excuse me, and then our point 4, 2. So we go over 4, 1, 2, 3, 4, and up 2. So graphing this out, it's going to look something like this. Right. Notice that when we plot this f or inverse, which is the square root of x, it only gives us positive y values. Like I said before, if we put a negative value into underneath a square root, it doesn't exist. It's an imaginary number. And if you were to have, let's say we were to have negative y values here, because this is an inverse, so we know that this that our inverse is a reflection of our original function across our line y equals x. So technically we should have, if this was a true reflection, we'd have something right here. But if you notice, this isn't passing our vertical line test. So this wouldn't be a function. So that's why we focus on the positive values of our square root function. All right. So we're looking at our next example. We have graph y equals square root x plus 2. We need to state the domain, range, x, and y intercepts. So we have our table of values here on the left. And so what we're going to do is just plug in values into our function and get our get our y values. So this, if we have x equals -3, we have the square root of -3 plus 2 gives us the square root of -1. It is undefined here. Undefined. It's an imaginary number. We have a negative underneath a square root. We can't do that. All right, so if we plug in -2, we have -2 plus 2 gives us the square root of 0, which is equal to 0. If we plug in -1, we have -1 plus 2 gives us the square root of 1, which is equal to 1. If we plug in 0, we have 0 plus 2, or the square root of 0 plus 2, and then that is equal to the square root of 2, which if you place into your calculator, it was around 1.4. And then if we plug in one more value here, we have the square root of 1 plus 2. That's equal to the square root of 3, which placing into your calculator, you're going to get around 1.7. So if we plot these values here, so we'll start, obviously we can't start with our x equals -3, so we'll start at our x equals -2. So at x equals -2, we have the point 0, so over 2 and up none, it's a 0, so there's our point. And then at -1, we have our y value of 1. And then at 0, we have around 1.4. So if we, this is our 0, and it's kind of around here. And then at 1, we have 1.7, so it's going to be around here. Remember, this is a rough sketch of our graph. This isn't going to be completely accurate. All right, so our x-intercept is where our graph intersects the x-axis. So it looks like it's hitting our x-axis at this point right here. And so that would be x equals -2. We can write this as -2, 0. Basically, your x-intercept is when y equals 0. All right? And for your y-intercept is just the opposite. When your x value, when your x equals 0. So when x equals 0, you notice this point right here. So we have 0, and remember our point at 0 was around 1.4 or the square root of 2. All right, so the domain, just a little refresher on the domain, is all possible x values of this that exist for this function, all possible x values. So if you notice our function, it starts right here. There's no values, x values, going past our point -2. So our domain is x is greater than or equal to -2. And as far as our range, it's all possible y values. All possible y values. So if we look at our graph, notice that we have no y values below our x-axis or below our y equals 0. So we know that our range is y is greater than or equal to 0. So a couple math rules to live by. Just a few kind of reminders. We will have to keep these rules in mind, especially throughout this entire chapter. Is we can't divide by 0. It's basically having your 0 in the denominator. It's undefined. We can't do it. We can't take the square root of a negative number. It's an imaginary number. Just kind of scroll all the way down here. So number 3, we can't have negative exponents in your simplified answer. We learned that back in chapter 6. And number 4, we cannot have radicals in the denominator. And number 5, we shouldn't have fractional exponents in the denominator. So these are just a couple things we need to keep in mind for this unit, just so we get the correct answers. So just a couple things. To find the domain of a square root function, we're kind of really focusing on the square root function, this unit, or this notes. So the radicand has to be greater than or equal to 0. The radicand is everything underneath the radical. So underneath the radical sign. All right. So the radical, so everything, basically everything underneath the radical sign has to be greater than or equal to 0, and that's how we'll find the domain of our square root functions. So how we find the domain of the square root functions is we set the radicand greater than or equal to 0 and then solve for x. So we have a couple examples here. Let's see. So we have 4x, the square root of 4x plus 2. Our radicand is our 4x plus 2. So to find our domain, we need to set 4x plus 2 greater than or equal to 0. So solving for x, we subtract 2 from both sides. So we have 4x is greater than or equal to negative 2. And then getting the x alone, we divide by 4, which gives us a negative 1/2. So our domain is x has to be greater than or equal to a negative 1/2. And that is the domain for that function. Looking at our next function, we have y equals the square root of 2x minus 3 plus 4. Notice we set only the radicand greater than or equal to 0. So we're only taking this 2x minus 3 greater than or equal to 0. So 2x minus 3 is greater than or equal to 0. And then we solve for x. So we're going to add 3 to both sides. So we have 2x is greater than or equal to 3. And then divide by 2 to get the x alone. So x is greater than or equal to 3/2 is our domain for this function. Remember, you can always pause and stop the video if you need more time to write things down or if you just need more time to process things. Now, if we're looking at the range of a square root function, if we remember the range is all possible y values of a function, we're just looking at the number after the radical. So we have y equals the square root of ax plus b equals, not equals, y equals the square root of ax plus b plus c. All right, and so our number, we're going to focus on the c number here. If we don't have a c number, if there's nothing there, and there's no number after the radical, then the range of the function is y is greater than or equal to 0. If there is a number, then the range is y is greater than or equal to that number. So if we look at the two, examples that we did earlier, notice we're stating the domain x that we already found, so x is greater than or equal to negative 1/2. Notice we have nothing after the radical here, so we have plus 0. So as stated above, if there's no number after the radical, then our range of the function is y is greater than or equal to 0. If we look at our second function here, we'll notice that we have the domain that we found, x is greater than or equal to 3/2. But we do have a number, we have plus 4. So as stated above, if there is a number, then the range is y is greater than or equal to that number. So our range is y is greater than or equal to our number here, so 4. And I think that's going to conclude our video for today. Please remember to check back into Schoology and take your Schoology quiz, and we'll finish the rest of the notes tomorrow. Have a nice night.